All right, this is Mr. Smith here. We're looking at section 6.2, properties of rational exponents. So in section 6.1, we kind of had an introduction into rational exponents. And when we say rational, we mean fractional. Okay, so they're written as a fraction. They're no longer integer values, they're fractions. Okay, and today we're going to expand upon that to some depth. Okay. Again, the vision here is that we'd be able to solve equations in the future. Okay, so that's what we're pressing towards. And so we have this chart of properties. We have seen this chart before. Okay, we've seen it before. It's just M and N, when we talked about these before, they were always integer values, and now they are going to be fractions. That means we're going to be doing operations here like this one, where if I'm multiplying two powers that have the same base, we add the exponents. Except now we're adding exponents that are going to be fractions. Okay. Probably the property that's going to get used a lot by the end of this section is this one, and we're going to go backwards. So I'm going to have a to some power m, and I'm going to have a different power or a different base b to also the same power m, and so we're going to rewrite it as a times b to the mth power. Okay, we're going to be using that property a lot. We'll see it in division a little bit, where I have a to the mth over b to the m power, and on this one, again, we're going to come back and rewrite it like this as a over b all to the mth power. And the reason we'll do this in both cases is because now I'll be able to evaluate what a times b is, and here I'll be able to divide by a divided by b, and that'll allow me to simplify the problem a little bit more. Okay. So here are some introductory examples for us to apply the properties to. Okay. So this first one in letter A, I see I have 9 to the 1/2 power times 9 to the 3/4 power. So both have the same base. So to find what the new power is, we add the exponents. Okay, so 9 to the 1/2. So we need to be able to add fractions, we need a common denominator. So 9 to the 2/4 times 9 to the 3/4 equals 9 to the 2/4 plus 3/4, which is 9 to the 5/4. Okay, and this is just an application of the first property. We simply add the exponents together. We could try to simplify 9 to the 5/4, but the 4th root of 9, there isn't going to be a nice value there. So for now, for these problems, let's just leave our answer and not worry about trying to simplify it further. Example B, I notice that we have two different bases. Okay, so we're not going to try to combine those in any way. We have two different bases there. But I have both of these being taken to the third power. Okay, so the property from the previous slide, I believe was the second one, allows us to take this exponent and apply it to both pieces. And the way we do that is through multiplication. Okay. So the resulting power is going to be 7 to the 2/3 power times 3, 7 to the 2/3 power times 3, times 5 to the 1/6 power times 3. And this first one, the 3's cancel out, and this leaves me just 7 squared. And in the second piece, this is going to give me 3/6 power. So this will be 5 to the 1/2 power. Okay. Are there any questions there? If you wanted to write this as 7 squared as 49, you could. Doesn't matter. I trust you know that. In part C, I see that I have both the same bases, 3 to the 5/6 power, 3 to the 1/3 power. So we're going to use the rule of division that allows me to subtract this. So this will be 3 to the 5/6 power minus the 1/3 power. Now, of course, we need a common denominator, so that would be, again, 6. So we get 2 over 6. Okay, so 5/6 minus 2/6. And so we're left with 3 to the 1/2 power. And on the last one, I see that I have 2 different bases here. Okay, so it's going to be imperative that you pay attention to when the bases are the same and when the bases are different. Because if they're the same, there are certain rules that we're allowed to do that we're not allowed if they're different. However, both of these powers are being taken to the 2/3 power, right? We have exponents of 2/3 both here and here. And so what we're going to do is, as I mentioned on this previous slide, we're going to take this setup and we're going to rewrite it so we have one fraction all to the 2/3 power. Okay. And so what we're going to do is we'll rewrite everything in here as 16 divided by 4 all to the 2/3 power, okay, and all of that then to the 4th power. And the reason we want to do that is because I know what 16 divided by 4 is. Right, 16 divided by 4 is just 4. And so this simplifies out as 4 to the 2/3 power, now to the 4th power. And the rule here is multiplication, so we multiply the exponents, and it gives us 4 to the 8/3 power. 4 to the 8/3 power. Okay. Okay, so here we have 2 properties dealing with radicals, but again, these are just restatements of 2 of the properties we saw with our rational exponents from the first slide. Okay. All right, so here we are. And by implementing these 2 properties, we can simplify these 2 problems. So here, the property says I'm allowed to multiply 9 times 27, and we get 243. And now I can take the 5th root of that. And we're going to go backwards and forwards on these problems. Sometimes I'm going to give you something like this, and we're going to split it up. In fact, we're going to do that here shortly. Other times I give you these 2, and it's more convenient to multiply them, to combine them, because when I take the 5th root of 243, we just get back to 3. Okay. So here I can't simplify this further. I can't simplify this further, but when I multiply them together, I can now simplify further. On this one, we can bring these together, all under the same cube root. So again, just an application of our properties. And now 192 divided by 3 is 64. So this becomes the cube root of 64, which is just 4. Okay. All right, so here are 2 problems. For those of you in my class and for those of you watching at home, if you pause the video now and work on these 2 problems, we'll go over the solutions when the video resumes. Please pause the video now. Okay. On this first one, we can apply this -1/6 into both pieces at the very beginning, or we can combine the 6 and the 5, and then work on the negative 1/6 later. I think I'll bring in the negative 1/6 to begin with. And so it gives us 6 to the 6th power times negative 1/6 times 5 to the 6th times negative 1/6 power. And so basically this is just 6 to the negative 1st times 5 to the negative 1st, which is 1 over 6 times 1 over 5. 1 over 6 times 1 over 5, which is just 1/30th. Again, it doesn't matter which step you do first. You have to do both steps at some point. On the second problem, we're going to consider this as the square root of 245 or the square root of 5, so we'll bring it all under one square root. And 245 divided by 5 is 49. Okay. And so this gives us a square root of 49, which is 7, and we can consider it plus minus 7 or just 7, depending on what type of problem we're doing. Okay. All right. So now we come to the idea of simplifying roots. And before we get on to this problem, and we'll get there, and actually let me look ahead briefly. Okay, I want to do this as well, 4th root of 48. But before we get on to those, I want to review how we do this with square roots. So let's say I had the square root of 20. And I ask you to simplify that. So the way we do this is we break the square root of 20, we break 20 up into 2 factors. But we're looking for a very specific factor. I don't want to break this up into 10 times 2, for instance. I don't break it up that way. I want to break it up in such a way that there's a perfect square. Okay. And so we break the square root of 20 up into the square root of 4 times the square root of 5. And the reason we do that is because the square root of 4 is just 2, and it leaves us 2 square root of 5. That idea is what is going to be underlying when we work with 5th roots and 4th roots, except instead of looking for perfect squares, we're going to be looking for perfect fifths, and we're going to be looking for perfect fourths. Okay, so let's now take a look at the 5th root of 128. So I need to break that out into 2 factors. One of them has to be a perfect fifth. Okay. So let's see. And again, there's going to be lots of ways to break this out, but the way that I think we're going to want to do it is the 5th root of 32 times the 5th root of 4. Because 4 times 32 is 128. 4 times 32 is 128. But the reason I chose those 2 factors is because the 5th root of 32, 32 is a perfect fifth, and the 5th root of 32 is just 2, so it leaves us 2 with the 5th root of 4. And that is simplified or simplest form. Okay. That is simplest form. So when we look at working on a 4th root, I'm going to look for a perfect 4th. Okay, 48 isn't a perfect 4th root. It's not perfect 4th. So I need to break this up into 2 factors. And there's lots of ways you could break it up, but you want to break it up in such a way that we find a perfect 4th. And so in this case, I believe we're going to look for the 4th root of 16 times the 4th root of 3. Again, 16 times 3 is 48, but 16 is a perfect 4th. Okay, and the 4th root of 16 is just 2, so it leaves us 2 times the 4th root of 3. So certainly there are other multiples that get us to 48. The question is there another factor pair we could use? So for instance, 12 and 4. 12 times 4 is 48. However, 12 is not a perfect fourth root, and 4 is not a perfect fourth root. So the answer is no. It's actually got to be this way. Okay? Go ahead. Where do you begin? So how do you know how to do it? So I would tell you that you need to know some basic fifth roots. So what I would do is I would go through my list of perfect fifths. So the very first one is 32. If 32 is not an option, now I'd see what's 3 to the 5th power. Okay, so I pull my calculator. 3 5th power is 243. Okay, so now I'd look for, could I divide 128 by 243? Okay, and these numbers are going to get really big really quickly, so you should expect that most of these values here are going to be pretty small. It'll be 3 to the 5th power. It'll be 4 to the 5th power. It's not going to be 19 to the 5th power. Okay, so start small, and I'll try to keep the numbers manageable for you. Okay. All right. So this now builds. We're going to take this idea and we're going to build on it. And so I want you to remember that the fourth root of 48, is 2 times the fourth root of 3. Because we're going to do this problem on Part B. And I'm going to modify it a little. Okay. So I want to make that addition. And so they ask us, hey, what's the fourth root of 48 plus the fourth root of 3? Now the rule is you're not allowed to add square roots, or you're not allowed to add roots unless it's the same root, same degree root, with the same number underneath. Okay, so I can't add these two as they are. I need to have the same root, which it is both the fourth roots. However, I have to have the same number underneath. This is 48, this is 3. You're not allowed to add those. However, we just saw in the last problem that the fourth root of 48 can be rewritten. All right, the fourth root of 48, look on your notes. For you, it's all right there. Should just be what? 2 times the fourth root of 3. All right, so the fourth root of 48 is this, plus I have another fourth root of 3. Okay. So I have 2 fourth roots of 3, and I'm going to add another fourth root of 3. So how many fourth roots of 3 do we have? We have 3. So the answer here is 3 times the fourth root of 3. Okay, we're adding fourth roots of 3. I had 2 in one hand. I have 1 in the other. I add them together and I get 3 times fourth root of 3. Okay. So again, the rule is to be able to add them, we have to have the same degree root. You can't add a fourth root and a third root. Okay. And we have to have the same number underneath. So here we have 3, here we have 3. So now we can add those. Okay. Likewise, in Part A, if we look at Part A, I see that I have 12 to the 2/3 power, 12 to the 2/3 power. Okay, so I have the same root, right? Notice it's the 2/3 root. It's the 2/3 root, so I have the same root. I have the same number as the base. Same number as the base. Again, we're allowed to add these. So I have 2 of them here, and I'm going to add 7 more. So we get 9 times the 12th root, the 12 to the 2/3 power. Again, we're only allowed to add as long as we have the same root and the same base. And usually what's going to happen is you're going to have to simplify first, like we did on our first example. Okay. So at this point, we're going to pause here, and we'll end Part 1, and we'll continue with Part 2 tomorrow. I would encourage all my students to look through at least half the homework problems, because they're going to take a little bit more time. They're going to be more demanding. Thanks for your attention. Have a good day.